If we have light incident on a transparent medium with n on the left and n prime on the right, some of the light will be reflected back into the original medium, and some of the light will be transmitted through into the second medium. When the incident ray is perpendicular to the interface, or when the angle of incidence is 0, we can use Fresnel's law of reflection to calculate the percentage of light that is reflected. Our formula for that, we just need to know the index of refraction for each medium. And we use n prime minus n over n prime plus n squared. And to put that into percentage format, you'd multiply by 100. And then if this is transparent, we can assume that the amount of absorption is negligible. And so we could say that 100 minus the value that you got here, the percent reflected, is equal to the percent transmitted. For our example, I'll show how much light is reflected at an air-water interface, a water-air interface, and then a water-glass interface. So for the air-water interface, the light is initially in the air, so your N is equal to 1.0, and then some is reflected off of that back into the air, and some is transmitted through into the water, where your N prime is 1.33. And if we use our formula, 1.33 minus 1 over 1.33 plus 1 and squared multiplied by 100 would give us 2.01%. Now if we do the same thing for water air, this time our N is 1.33 because the light was in the water first, and our N prime is 1.0. So this time we say 1.0 minus 1.33 over 1.0 plus 1.33 squared and times 100, and you end up with the exact same percentage. So this is showing you that it doesn't matter which is n and which is n prime, that the amount reflected at that interface is going to be the same amount. It doesn't matter which direction the light is traveling. And now let's look at the water-glass interface. For this we have the light in the water first, where n is 1.33, and we'll use an index of 1.523 for our glass, for n prime. So 1.523 minus 1.33 over 1.523 plus 1.33 squared and times 100, and that will give us a much smaller value of 0.46%. And what this is showing you is that when the n and the n prime are closer together, there's not as much difference between the two, that less light is going to be reflected. When there's a greater difference between the n and the n prime, like that between air and water, then more light would be reflected at that surface.